So we'll kind of gauge as we go through if we remember or recall doing this in algebra. So first thing I'm going to start with solve by completing the square is this idea of perfect square trinomials. A really important, really essential to this concept of completing the square is what are perfect square trinomials? They are trinomials whose two factors are exactly the same. So the definition of a perfect square just doesn't change just because it's a trinomial. It's still the same idea. Now I have the same examples that were on the previous slide where you factored to find them. So if you want to write some examples of perfect square trinomials, if you didn't write down your warm-up, you could write some examples down now. And I have mine color-coded only to point out, like, as you look at those numbers, there are some patterns or connections, right? So these are the same ones that we just looked at, and we actually already talked about the patterns. So for each of the red numbers, how are they related to your green number? Multiplied by itself. These are the square roots of the last number. Okay, so the red number is the square root of the last number. As you look at those red numbers in the final answer, how do they relate to the blue number? They are half of the middle term. Okay, so that's going to be an idea important for us, okay, as we work to complete the square. Okay, so there are going to be some problems on your homework that are going to be simple and just ask you to complete the square. Eventually we're going to move in the next few examples to solve by completing the square, but this is just like, can you practice the skill of finding the number that completes the square? So it says, find the value of C that creates a perfect square trinomial and then write it as the square of a binomial. So that's that group of parentheses being squared. So you have two terms inside. So we've got x squared plus 8x plus c. And we have x squared minus 16x plus c. You may take a quick moment here to think about, what do you think the value of c is? And if you know the value of c, what would your square of your binomial look like? So think about, okay, if I factored that, what would be my two groups of parentheses? And you can think about the pattern that we described on the previous slide. Chat with your group members for me. Do you agree on the value of c? Do you agree for the square of your binomial? If you disagree, try to argue your case. Why is yours right? Okay, Abby, tell me what you guys chose for C in the first one. C equals 16? Okay, and then what was your square of your binomial? Okay, excellent. So you want, how did you find the number 16?
What I did was I just divided 8 by 2 and then I got 4 and I just squared it.
Okay, excellent. So one method to find the number that completes the square is we're going to say take half of the middle number and square it. So what Abby described. She took half of 8, which was 4, because that will be the number that goes in the parentheses, right? Half of 8. And then that also has to be the square root of the last number, so just square it, and that's whatever the constant is. Okay. So what did we get for our C value? X squared minus 16x plus C. Ashlyn, what did your group say?
We got 16. 64. Oh, for that one, 64.
Okay, for this one we get C equals 64. And what was your binomial squared?
Oh, 8. Yeah,
X minus 8. Okay. So how can you make sure that you have the correct sign in your binomial? You could plug it in. What else could you be looking at? Aiden?
The signs in the trinomial.
The sign in the trinomial. You're specifically looking at the sign of the middle number, right? If they're both positive, then the middle number is going to be positive. If they're both negative, then the middle number is going to be negative. But notice, when you're plugging in these numbers, this 16 and this 64, they should both be positives. So it's always going to be plus the perfect square. Never will it be minus there. Okay. Now we could use that same method on the 16x plus c. Take half of 16 is negative 8. Square it. It's still positive 64. Okay. Go ahead and see if you can do the last two on your own. I'll put up my answers here momentarily. So x squared minus 2x plus c. And x squared plus 22x plus c. Okay, you find the value of c, the number that completes the square. You can use the tip that Abby gave us. If I use Abby's tip for taking half of the middle term and squaring it, I would be taking half of negative 2, which would be negative 2 divided by 2, and then I would square it. So that'll be negative 1 squared, which is positive 1, so c equals 1. And then my binomial squared will look like x minus 1. 1 is the square root of 1 and half of 2. A lot of times this one is an easy one. People will take half of 2 or negative 2 and they'll get negative 1 and then they'll tell me that that's 2 when they square it. So just remember 1 squared is 1, not 2. And then this one we could do the same method, 22 divided by 2, quantity squared. That's 11 squared, which is 121. So that would be x plus 11, quantity squared. Now, I've been nice so far and given you all even numbers, right? So just down below here, we'll do an example. I'll just make one up where it is not an even number. So let's do x squared plus 5x plus c. So we could follow the same rule that Abby gave us, which is take half of the middle term. The only thing about this is that doesn't come out nice, right? So you could certainly say it's 2.5 squared. I'm also okay with fractions, and the more you're okay with fractions, the easier your higher level math is going to be, because a lot of times we leave stuff in fraction form. So I'm just going to leave it as 5 halves squared, and then I square the numerator and square the denominator. So that's really 25 over 4. Okay, so C, the number that completes the square, is 25 over 4. When I write my square of my binomial, I want to do whatever was half of the middle term, or the square root of 25 over 4, which happens to be 5 halves. No big deal. It's okay to have decimals or fractions. Now this one, if you use a decimal, that's fine because it's going to be like a 0.5.
0.25.
No worries there. All right, questions or concerns so far? Okie doke. Let's solve by completing the square. Okay, so first off, if you saw this problem on a future quiz or test, x squared minus 8x plus 5 equals 0. The first thing I would say you should do is attempt to factor it. If you have x squared and x in an equation, probably the easiest and quickest method is factoring. So I always like to work smarter, not harder. If something could be factored, I would. Are there factors of 5 that add to make -8?
No.
So that means it's not factorable. Eventually, we're going to get to quadratic formula, which I saw some people using already. But we're not there yet, so we're going to just solve by completing the square. So here are the steps to completing the square. First thing you want to do, move the constant to the other side. Now get it out of the way. It really has nothing to do with completing the square. The completing of the square is for the x squared and the x term. So it says isolate x squared and x. So if I move my constant to the other side, that's going to be x squared minus 8x equals -5. Now, I do leave a little bit of space there because I do know ahead of time I'm going to complete the square, so I need a place to put that number. So I like to leave space for it. You don't have to if you don't want to. Oh, I say leave space to complete the square. Okay. Now you're going to complete the square. And I already wrote this down on a previous slide. If you want to write it down in your notebook and you haven't yet, you are responsible for knowing the skill of completing the square, which is that pattern that we noticed and what Abby described for us. So she said, take half of the middle term and square it. Now, when you complete the square, you'll find a number. You'll plug it in on that left side. So for x squared minus 8x, what number completes the square? 16. Okay, we're taking -8 divided by 2, squaring it. So that's -4 squared, which is positive 16. So I'm going to put a plus 16 right there. If I put it in red so it stands out, I just added that to one side of the equation. To keep the balance of my equation, I must add it to the other side. So the 16 wasn't there originally. I put it in there. So I have to rebalance my equation. I'm going to put a plus 16. Okay, so that's why it says add to both sides. What you do to one side, you have to do to the other. Golden rule of algebra. Okay, next step. Rewrite your trinomial as the square of a binomial. So you just completed the square for a very specific reason, because you can now factor x squared minus 8x plus 16. It's x minus 4 times x minus 4, and we can write that as x minus 4 squared. And on the other side, -5 plus 16 is 11. What's that? Oh, can we solve for x?
No.
What would we do? Square root. And then add 4. Remember, when you square root, what must happen in your work? You must add the plus or minus immediately. Okay. So then we can solve by taking square roots. You've just created it into an equation that we studied earlier this week. It has one x in it. There's no more x squared in x. So I can solve by taking square roots. We've rearranged things to make it more solvable for ourselves. So we're going to square root both sides. That's going to give me x minus 4 equals plus or minus the square root of 11. Okay. Remember, it's going to go right in front of your square root. Square root of 11, not imaginary, so don't have to worry about I. Doesn't simplify, doesn't have any perfect square factors. So then just leave it as square root of 11, and my final answer is x equals 4 plus or minus the square root of 11. So now you can see this is not factorable. There's no way you would come up with those two irrational numbers as factors. 4 plus square root 11, 4 minus square root 11.
Why do we say perfect square instead of just square?
Where?
Just like you've been saying, like
Perfect square
doesn't have a
trinomial?
perfect square. Yeah. Why isn't it just square trinomial?
I don't know.
The squares can't technically be not perfect.
Yeah.
Because they have to have even.
So
Amounts on
there's
each
no
side.
point to say perfect if a square is already perfect.
Although technically, the whole rule about squares.
Perhaps it's because it is all integers. Like, I mean, 6.25 is the square of 2.5, but maybe it's not a perfect square because it's a decimal. It's got a fraction.
So is it not a perfect square?
6.25 is not perfect, or yeah, you wouldn't. Like when I say list the perfect squares, don't you list 1,
Oh.
4, 9, 16? So I'm thinking it would be a perfect square in numbers because of integers. In trinomials, I don't know. I'll have to think about that maybe so that it has a leading coefficient of 1.
Nothing's really perfect
Yeah, a perfect square is perfect.
though. Nothing's perfect.
Okay, other questions or concerns? I can look into that. I don't know the exact answer, but my guess is it has something to do with the fact that it's like an integer. I've never really thought about it.
Is it square?
Other questions you have for me? Okay. Oh, sorry, what?
Sorry, no. I'm just saying, like, is that all that we're, like, doing with this?
Is that what?
All that we're doing with, like, the perfect square?
Solving? Yeah. That's our whole goal in this chapter is to solve the quadratic. So far we solved by graphing, we solved by taking square roots, and we solved by factoring. And now we're solving by completing the square, which is going to lead us to solve by quadratic formula. Okay. Can you try this one? Okay, write it down. I got the reminder tips on the side. If you wrote them down once, you really don't have to write the tips down again, right? Okay, I just have them as reminders for what we're doing. Okay, so you practice this one. Move your constant to the other side first. I like to leave space to complete my square. Now complete your square. Remember, to complete the square, you take half of the middle term, and then you square it, and you have to add it to both sides. So check with your group members right now. What are your first and second steps due to your equation? Chat. Okay. We should be something like this. We got positive 40 on the right. We put a plus 9 to complete the square. Okay, now finish.
Would you minus 9?
Nope. Yeah. If you add 9 here, then you have to add 9 on the other side. Now you could do minus 9 on the same side, but then that would be outside of your perfect square factors. So I always just like move the constant to the other side and do the work on the other side. But algebraically, you could minus 9 on the same side. I don't always recommend that. So keep solving. Now rewrite it as a perfect square trinomial. And solve by taking square roots.
Oh, I forgot. It's adding 9. I forgot a step. Okay.
So what's 3
Yeah,
plus
that's what I
7?
got. I got it.
3 plus 7. So those are 2 x's.
That's what I got. That's what I got.
Because square root of 49 is plus 1.
You throw your plus or minus. You're in algebra 2, Dylan. You gotta remember. Okay.
I had the recipe.
X minus 3 quantity squared equals 49. Then we solve by taking square roots, so we're going to put a square root here. And then we get x minus 3 equals
Positive negative 7.
plus or minus 7. Remember, it is imperative for you to get the correct answer that you put the plus or minus in at that moment. Okay? Has to be right there after you square root. Then you can add 3. I always like to put it in front of my plus or minus. It makes it easier for me because now I have 2 numbers, right, that are integers. I could actually add those and subtract them. So I have 3 plus 7 and 3 minus 7, which is 10 and negative 4. So you gotta be careful there. Just because you add 3 doesn't mean it's gonna be plus or minus 10. A lot of people had that on their paper, so we have to be really careful there. And if you come up with 2 integer or 2, I should say, rational answers, it could even be if they're fractions. What does that mean if your solutions are fractions or integers? How could you have solved the problem in the first place? Factoring. Do you have factors of negative 40 that add to make negative 6? 10 and 4 if 10 is negative. Okay, so you could have written this out as x minus 10 and x plus 4 equals 0. And then set your factors equal to 0 and x equals 10 and x equals negative 4. And you see how much less time that took me? Whew. So it's always worth the while on the beginning to check to see if you could factor. That leads me down here to the bottom of my screen where I have my very first meme I ever created on my own. I went to the meme generator and I typed it in.
What's your first meme?
It's my very first and actually it's my only meme I've ever created, but it's a pretty good one. I solved by completing the square. Could have just factored. That's how I feel when I do that. Thanks, Jet. I think it's pretty good.
Good job, Miss
I would have, if that popped up on my feed, I would have laughed a little.
Yeah.
I would have given a little.
I should put it out there so that you guys can like put it out into the world, right? Do the thing. There's Miss Cronky's first meme. She's pretty proud of it. Okay. So let's do one more. Then you'll have some time to work. One more. You work it out. See if you can get the right answer. You can talk to your group members if you want. You can work alone if you want. Write it down and get started. Ask for help if you need it. You can leave your answer in exact form.
Square root of -9.
And you also want to check on your simplifying your radical.
Negative. Way before you did. Wait, no, not that. Him.
Now be careful how you move forward.
Max, why are you so weird?
What's this? It's a big one.
You gotta do the same thing to both sides. What we got up here?
Just lit up my screen. It's like
Yes.
Yeah, like I wanted to put it in, but I really don't want to put it in. Agreed to see.
Okay, I'm gonna put my work up here on the board so you can kind of check. I've gone around and checked most groups and had a few statements. I would begin by moving my 45 to the other side, which I have to use the inverse operation, so I'm going to be subtracting 45. Then I'll take half of 12, which is 6, square it to get 36. Because I added 36 on the left, I also have to add 36 on the right. And that leaves me with x plus 6 quantity squared equals now a negative 9. When I square root to solve, I'm taking the square root of a negative number, and now I know that my answer is imaginary. I have to put a plus or minus because I'm square rooting to solve. And I'll have x plus 6 over here, and I can actually do the square root of 9, right? It is 3. And then subtract 6, so x equals negative 6 plus or minus 3i. Now, I cannot add negative 6 plus 3, negative 6 minus 3 because they're not like terms. So I have two imaginary solutions. Negative 6 plus 3i and negative 6 minus 3i. Right? So that's another one where like you weren't able to factor that. There are no factors of 45 that add to make 12. So you would either have an irrational or an imaginary solution that you would need to complete the square to find. Okay. So you have a homework assignment this evening. This is probably an old one, so
I mean, we can do that though.
don't do this one. Whatever. Do the one that's on your gold sheet. I'll see if I can find it.
It's solving quadratics.
Your retakes are due Friday for your quiz or for your test. Oh no, we didn't. I didn't give your solving quadratics. So I'll update this tomorrow when I hand back your quiz. But your test retakes are tomorrow. I don't think that I have anybody scheduled.